All right, welcome back to KM6 LYW Radio, the show about amateur radio or ham radio with emphasis on data modes, moving information back and forth, reimagining amateur radio in the information age. Hey, today let's build an APRS packet tracker. We're going to use Raspberry Pi, a GPS, and radio, and we're going to build a tracker, this time on KM6 LYW Radio. There we go. There it is. Hey, all right, welcome back. I don't think that was a repeat. It seems like we've got an 80s and 90s theme, and thank you for the updates. We've done over 100 of these videos. I am running out of jingles, guys. That's our cheap bumper music, low production value. That way we can pass the savings on to you. So let's build this APRS tracker out of some stuff we've got here on the desk. So a little background on the APRS packet network. It's really like the data equivalent of your phone. So you got your mobile phone, sure you can do voice, but you can also do texting. Well, amateur radios can do the same thing, and the texting half of an amateur radio is what we called APRS. I think it's Advanced Packet Reporting System is what that stands for, and it's a global network. In the Americas, it's on 144.39 megahertz, and in Europe and other countries, it's on 144.8. So you can send tiny little bits of information out on this network, and it's bridged to the internet in a lot of places. So, you can send like your position, you can send text messages not only to other radios, but where there's an internet bridge, you can actually send messages back and forth to phones. So the APRS physical network is out there. It's for use by amateur radio operators. And this is a device that we're going to call an APRS tracker. Now, a lot of people think APRS is just a way to send your position with the GPS. And for a lot of radios that have APRS built in, that's kind of all they advertise or all they really use. And, I've kind of glazed over that because what I think APRS is for is really for text messaging, for sending messages back and forth and communicating, not just sending your position as you go back and forth to work every day. But, in doing so, I've kind of glazed over the fact that I've never actually built an APRS tracker, I think, on this channel. So this is a picture of one right here. This is a Raspberry Pi based solution. So on the bottom here, we have a Raspberry Pi 4, I think. That's what's underneath here. And on the top here, we're going to talk a little more about is a thing called a Raspberry Pi Hat. And it has all of the stuff you need on it to become an APRS tracker, including the little cable that's solderless. It has little screw terminals in there, a little cable that goes through to our very cheap Baofeng amateur radio, which is on APRS frequency right now, 144.39 in here in the Americas, and it's actually receiving stuff. I've got an ICOM 705 over here. It's just for looks. It's just so it looks sexy over there. And actually, it's the packet noise you can hear is coming over that. So that way you can hear both sides of the conversation when this receives and transmits. So this Raspberry Pi is actually running the DigiPi SD card image. And if you haven't heard of that yet, welcome to the channel. You probably haven't seen any of our other videos. So the DigiPi SD card image is at digipi.org and goes to patrons of the channel. You don't need DigiPi to do this, but it certainly makes it easier because all of this stuff is pre-configured. This DigiPi Hat also has two options on it. The first of which is this little guy up here that just plugs right in. It's totally optional. This is a GPS. And he has an antenna down here that, I don't know, you can put in a more clever location. And then over here, just for fun, there's a temperature sensor, so maybe you want your GPS, your APRS tracker to have, like, to report the temperature or some other interesting telemetry-based information. So I'm going to give you the URLs for all of this stuff here at the end, and I'll put them down in the notes on how to build this hardware. But for right now, know this is a Raspberry Pi. It's a DigiPi Hat on top of that, and a Baofeng radio connected to that, and that's pretty much it. So what we want to do is report our location using this GPS to the APRS network, which is going to eventually get us out on the internet. So for those of you not familiar with APRS and maybe Direwolf. Direwolf is the software that implements the packet radio stuff for Raspberry Pi, for Linux, for Windows. Let me see if I make this a little smaller. I actually have a command prompt open on this guy right now. Make this bigger. Hopefully you guys can read that. So I have a command prompt on here, and Direwolf is on this system. I could run Direwolf, and you can say what your config file is. We're going to set up a config file here on this Raspberry Pi. It's going to basically turn it into a tracker. Now, if you have a DigiPi, I'm just going to show you the quick edits here, but this could apply to any direwolf.conf file. So I'm going to do a vi direwolf.tnc.conf. This is the config file. And normally at the top of this, we have a P beacon, which stands for position beacon, and then you kind of hard code your latitude and longitude here, which is all well and good. But if we want to be a tracker, let's say we want to put this in a car, we want people to know our exact location at the moment, we want to add that GPS. So we're going to go ahead and read this GPS value and see if we can put that in our beacon here and make a tracker. So if you're using the Raspberry Pi or you have a P beacon, go ahead and comment out the P beacon line. That's this P beacon. And comment out means put a pound sign in front of it. Now in the DigiPi, I put some examples down here, and all you need to do is uncomment them and you're in business. So this is the APRS tracker. The first thing you want to do is uncomment the GPSD localhost line right here. Make sure that's no pound sign in front of it. And then create a T beacon. Now T, I think, stands for tracker beacon. And you can set up the initial delay. I set it for 3 seconds. That's just so we can get GPS lock. And this does it every minute. You should probably make it every 20 minutes. But hey, you know, for the video, you can make a symbol like a DigiPi. That could be a car or a balloon or the path. And you can put a comment in here. You can say anything you want. Like I just say DigiPi Hat Tracker. You know, this is the most simple beacon you can possibly make. I've got some other examples down there right now. But let's see if we can, I'm going to write that file out. And what I'm going to do is restart Direwolf. And I can do that on the DigiPi, if you have the DigiPi management interface, simply by, actually I'm going to turn on Direwolf. Direwolf is going online. You'll say DigiPi TNC over there, and it'll send a beacon out here. And you'll notice that line that I had just configured is now being displayed on the DigiPi. So this is the beacon that actually went out using that T beacon line. You can see it has, I am exactly 0 miles from myself right now, and you can see where it says DigiPi iGate and Tracker. That was that comment field, right? And then of course it has my call sign on there as well. And what's even cooler is if there's a real iGate out in the area, you can actually go out to a website called APRS.FI and give this out to people who want to know where you are. And this is APRS.FI, and sure enough, here is that beacon that I just sent out. It's on the internet already, right? Isn't that cool? So with using nothing more than RF, some power, a GPS, the DigiPi Hat, the DigiPi software image, and a Baofeng radio, I was able to send my position and status and a URL, my call sign, my little icon. I can send all of that to the internet, and anyone can see this. You can just do aprs.fi/your call sign. So we just sent a tracker beacon out. So you notice it's moving every now and then because I configured this to go off about every 1 minute, right? And the GPS precision isn't great. I don't know, I guess I can zoom it in a little bit. You can see how it's been moving me around a little bit. You can actually see the GPS resolution. This is the resolution of the universe. It's like the Planck length of GPS. So yeah, it is moving me around a little bit just based on the noise in the room here. But isn't that cool? We sent out our position to the network using nothing more than amateur radio. Now this is invaluable, you know, if you're like 4x4 off-roading, backpacking, you know, you can change your icon to a little walking dude. You can send out a distress signal, you know, everyone knows your location. So it's really kind of like the ultimate survival kind of thing, to let people know where you are at all times using the APRS tracker. Or maybe you want to put this on a car, and if someone takes your car, you can go pick it up by going to aprs.fi and find your car. All right, so let's mess with this a little more. Now we just did you know, just a simple comment here. This was cool, you know, it has a URL on it. Let's switch it up a little bit. Let's edit this. Instead of just having a T beacon that goes off every minute with the digi thing, let's change the let's go down, let's comment this one out. Let's do a different one. Let's do this guy down here. We're going to do T beacon line. It's going to be the same frequency. His symbol is going to be a balloon this time. And the comment doesn't have to just be something you type out. It can actually be a command. Any command you can run on the Linux system, the output of that command will become the comment for your beacon. So if we want to do, like, we could actually get information off of a website here and put that in our comment, in our beacon. So if we want to know, this is just an example, you could get the weather in Sacramento. So here's the curl command, which downloads a website basically in a command and displays it in text format. And then I'm going to say, I'm going to wttr.in, which is the web server, and I just want to get the weather for Sacramento. In fact, if I want, I could just run this manually, just so you guys can see what this looks like. Let's just run that command, and this is going to go into our comment. Well, as long as I get these backslashes right. And you can see how it says Sacramento, 13 degrees centigrade. So that should go out into our I'm going to go back into VI this here. That should go back out into our beacon. That output should say Sacramento 13 degrees centigrade. In fact, I noticed there's a little error in here. I'm going to get rid of this backslash. This wasn't necessary. All right, so now our tbeacon line should print the current weather downloaded from the internet. Let's see if we can do this. Assuming you have internet, right? Assuming your beacon thing has internet access. And now let's restart the TNC and see what our tracker does now. I'm going to turn it off here. And I'm going to turn it on. And it should send out that beacon of Sacramento's weather here if we're really lucky. Here it goes, and there we are. Now remember, we changed ourselves to a balloon this time, and we should also see the Sacramento weather here. Let's see what this looks like here. All right, there's Sacramento, 13 degrees centigrade, and we're a balloon now, and we're still 0 miles from ourselves. That's pretty cool. And this is what it'll look like in other radios too. Other radios will show you the icon, the distance, and that beacon comment text, which is pretty cool. All right, so what else can we do here? I mean, as far as, getting information from the internet, using curl and wget, your imagination's really the only limit. Well, that, and you only got about 60 characters or so. So let's do another tbeacon line here. Let's comment out this one, and let's do the temperature sensor. I remember I said there's a temperature sensor on this board. That's this little guy right here. Let's see if we can read the temperature from that dude and send that out in our tracker beacon. I have a little program here called temp.py that'll read that little device. In fact, we can run it. I'm going to run temp.py, and sure enough, the output of that program says DigiPi Tracker 70F. And we're in America, so we're going to use Fahrenheit now. I'll leave it up to you as an exercise to change that to centigrade. So what should happen now is it should read that sensor and put that in our position beacon the next time we send one. So I'm going to turn off the TNC, or our tracker, I should call it, and then I'm going to turn it back on. And here we go. Here it comes. There's our repeat. Oh no, someone else blotted us. We got overwritten. We didn't get repeated. I'm gonna recycle it again for you guys. This is a busy APRS network day, because it doesn't actually show the transmitted packet. It shows like the repeat. So I need a repeat on this. Here we go. All right, packet's going out, and it's back. There we are, KM6LYW-2. And I had to turn the volume down so we don't get stomped by the next station here. So at this point, you can see that it actually has the temperature of this little sensor displayed on there. So the temperature of the sensor is 70 degrees, and we see DigiPi Tracker, 70 degrees Fahrenheit. So it totally worked. We did 3 different types of trackers, one using some static information, another one using getting something from the internet, and another one just reading that sensor on the DigiPi Hat. All right, so that's your tracker. So you don't need a DigiPi to do this stuff, but it sure makes it easier. You can just follow this example here, taking a look at direwolf.conf. There are other videos on how to install Direwolf, set it up, how to hook it up to your radio. I've got a whole bunch of those. This DigiPi Hat here is probably the easiest way to hook it up to a dual band rig. However, if you just want to use something like this and you have a USB based radio, you can certainly hook that up. All you need is USB cable. It's just not that complicated. Also, if you just want to use a cheap GPS like this guy, this is like 15-20 bucks. You can plug this into a Raspberry Pi and get your GPS info the same way. For full disclosure, for setting up your GPS, you would want to go into etc default, GPSD. I don't want to CD into it. I want to look at the file. And then set up your devices. So on DigiPi, I have some examples. So for the ICOM 705, which has a built-in GPS, you would use TTY-ACM1. For the DigiPi Hat, you're going to uncomment this line to be TTY-USB1. And the generic dongle, like I just showed you, is going to be TTY-ACM0. And then the rest of the file you don't need to care about. So that's how you set that up. So that is it. We just made a tracker. Now back to the hardware. I know you guys are going to be asking about this. So the Raspberry Pi you can get anywhere you can get a Raspberry Pi. If you're going to use the Hat, you should go with the larger format one, not necessarily the Pi Zero. If you just want to use a GPS Pi Zero combo, you can certainly do that. So if you go out to Ella Kits or Parts, there's a thing called the DigiPi Hat, the new DigiPi Hat. Now, Ella kits are parts. These guys are legit. They actually built hardware around the DigiPi software image that we give out to patrons on this channel. So if you're a patron of the channel, you get the DigiPi software image, which works perfectly with the DigiPi Hat. I worked with these guys. They called me up and say, hey, Craig, we got this cool hardware. Get the DigiPi Hat. So you can hook it up to your radio with no soldering, no fuss. The sound card's built in. The screen is built in. It has a GPS option. It has a temperature sensor. It is an amazing piece of hardware. I feel like a salesman. And the base unit here, just the board itself, is $34. So you can add like the GPS sensor, you can add the GPS, the BME 680, and a 3D printed case for a Pi 4, and you're looking at $50 for basically everything you see up here. So it's a pretty cool deal, and it's a really easy way to hook up your dual band rig to your radio. Now, if you've got a really overpriced, expensive USB-based radio like this, you don't need this hat, okay? You don't need the DigiPi Hat, because all of the information, the audio and the text, everything goes over a USB cable. So all you need to hook up your big expensive radio is a Raspberry Pi and a USB cable. But in this case, we wanted to use the Baofeng. This is the infinitely cheap radio that we just used, which worked perfectly, as you could tell. And then we've got the overpriced, well, it's a really nice radio, ICOM 705 over there that'll work very similar with just a USB cable. So the DigiPi software itself, if you go out to digipi.org, you can get that SD card image and jam it in this Raspberry Pi. And this goes to patrons of the channel. Anything helps, guys. We have a Discord channel, a Google group. We've got literally over 1,000 users now. It's insane. So everyone's helping each other learn what they don't and share what they do. So digipi.org, and again, patrons of the channel. Speaking of patrons, thank you guys. There are so many now. I can't possibly scroll through all of these in any. Well, let me go to the top here. It's patreon.com/KM6LYW. That'll get you access to this SD card image, which will do everything that you just saw here. So Steve, Mark, Andrew, Fu, Brian, Chris, Malcolm, Paul, Jim, Jeremy, Buddy, Robert, Kevin, Eddie, Aaron. Thank you, Aaron. Ham Radio Outlet, Aaron. Thank you, Scott, W0LED, Matthew, Q1Q. Thank you so much. Appreciate it, guys. I need like a slow scroller here or something. So I use a Linux desktop, so I'm not sure how to scroll through these. Like, it's unbelievable, guys. There's like 1,000 of you now. So, you know, if you hit like and subscribe, there will be even more digital mode users out there, and we'll have more people to talk to. But if you think about it, you know, all of these people are now using data modes on amateur radio in an easy to use way using the DigiPi image, which requires nothing more than a Raspberry Pi and a web browser. That's all you need on your network. And it'll run all kinds of cool modes. It'll run FT8, JS8 call, all the APRS modes, AX.25 networking. It even has a bulletin board. It's every access to every data mode there is on digipi.org using nothing more than your web browser or a connected Wi-Fi device. All right, guys, thank you so much for listening here. I don't know, I'm going to put myself back on. Thanks for listening today. I really appreciate it. My name is Craig, call sign KM6LYW. I am in California, and I am clear.